Hey everybody. So tonight I'm going to be going over some of the questions from the exam that people seem to struggle the most with. I won't be going over all the questions. I'll be focusing on the ones that people have the most trouble with. So if you have questions after you review your exam, the exams will have some response for each question about what was needed to figure out the answer. If you still have questions after looking at that, please feel free to make an appointment to come to my office hours or Professor Waldron's office hours, or you can also ask questions, obviously, during the lab, or you can email me separately and I can provide you a response via email as well. So I also apologize for starting late. I had a little bit of technical difficulty. I'll also point out that I am doing this from my home computer tonight, so I'm on a Mac tonight, so things might look a little bit differently. And also, I apologize if there's any issue with viewing the video. I tried to make my resolution a little bit larger than it usually is to help make it more visible for people. But if it is difficult to see, I do apologize. Hopefully, the audio will at least be enough to help you get a sense of where you might have gone wrong with some of these questions. Okay, so I'm going to start off with the first set of questions, where we had a histogram for the length of stay in a hospital. And so the question gave you the histogram. And so the first thing that you want to do when you get a question like this is look at the histogram and figure out what it is you're seeing. So as always with a histogram, we have the frequency along this axis, and the frequency tells us how many people are in each bin. And then at the bottom, we have the bin, and what the bin stands for is the length of stay in days the people were in the hospital. Okay. So the next thing that we want to do is to answer these questions, what we're going to need to do is figure out the total number of people that we have in each of these categories. And so the first thing you need to really be able to do is look at this and say, okay, this is 2 people, this is 4 people, this is 2 people, 2, 2, 2, 2, 2, this is 3 people, and this is 1 person. If you're not getting that, you need to take a ruler to the screen or something and line up those line up the bars with the frequency numbers so that you can figure that out, because without knowing that, you won't be able to answer the question. Okay, so the next thing is we know that we have 20 records. And the first question that people struggled with was question 2. What is the probability of staying in the center for more than 13 days, not including exactly 13 days? So the probability of staying in the hospital for more than 13 days in this case is just the probability of staying in the hospital for 14 days. Now, the histogram could have had 15, 16, 17, 18, in which case it would have been the probability of staying in the hospital for any of those number of days. But here we only need to calculate the probability of staying in the hospital for 14 days. And so in order to do that, we just need to know how many people stayed in the hospital for 14 days. The answer to that is 1, as we talked about before. And then all we have to do is divide 1 by the total sample size. So if we go into Excel and we do equals 1 divided by 20, which is the number of people who stayed for 14 days divided by the total number of people, we get the answer 0.05. And 0.05 is the answer to this question, which is also the fraction 1 out of 20 people. The next thing that the question asked you to do was estimate the median of the sample. Now, what we noticed was that it seemed like a couple of people got tripped up by this question, and maybe we're thinking about the mode in the sample. Remember that the median in the sample is the 50th percentile. It is the middle point in the distribution. And because we have 20 people in our sample, which is an even number, we also know that the median is going to be the average of the 2 middle people, because there's no 1 middle person. If you have an odd number of people in your sample, then the median is exactly the value of the middle person, which there is in an odd number of people. But if there's not an odd number of people, you have an even number of people, then what you have to do is take the average of the values of the 2 middle people. So in this case, we just need to count until we get to the 10th person, and then it's going to be the average of the 10th person score and the 11th person score. So here we have 2 plus 4 is 6, 8, 10. Okay, so the 10th person has a score of 9, and the 11th person has a score of 10. All you have to do then is take the average of 9 and 10, which is 9 plus 10 divided by 2. If you can't do that in your head, you can just do equals 9 plus 10. Remember to put those parentheses there for order of operations, divided by 2. And so the average of those two values is 9.5. And so the median in this case is 9.5. Okay. Moving on. I'm skipping a lot of the questions that most people didn't have trouble with. But like I said before, if you did personally have trouble with those, I am happy to review those with you during my office hours next week. Feel free to make an appointment with me. You can also, again, like I said before, you can ask about those during office hours on Sunday or during the lab on Saturday as well. Excuse me. Sorry about that. Okay. So the next question that people struggled with was question 13. So the question was, in any given year, 1 in 3 Americans over the age of 65 will experience a fall. If you have 4 living grandparents over the age of 65 and assume that the probability of a fall for each grandparent is independent, which is needed to be able to use the binomial distribution, the first question is, what is the probability that none of the 4 grandparents will experience a fall? Well, what we need to gather from this is a few different pieces of information. The first piece of information is the value that we're hoping to test. We're going to use the binomial distribution. So I'm going to start off by doing my binom.dist. And then I need the number. So the number in this case is the probability that none of the 4 grandparents will fall. So none is obviously 0. So we're looking for the probability of 0 falls. The number of trials that we're talking about here is the total number of grandparents that you have. So the next answer is the 4. Oops. 0, 4. Next thing we need is the probability. So the probability of falling, we were already told, is 1 in 3. And so you can literally just type 1 divided by 3 there. If you know that 1/3 is also equal to 0.33333 repeating, then you can type in a bunch of 3s to enough decimal points that it would be accurate. But Excel will also accept the 1 divided by 3 there. And then here, the question is whether or not we want a cumulative probability. In this case, I will point out to you that the difference, that there is no difference. It actually doesn't matter. We could say true or we could say false here. Because specifically in this case, we're looking for the probability of 0, which is the very first value. It's the least value in a number of trials. It's none of the trials. The cumulative and the non-cumulative probabilities will be identical. Now, if we were doing any other number, if we were doing 1, 2, 3, or 4, we would need to know whether we wanted to know the probability of exactly 1 grandparent falling, in which case cumulative would be true, or if we wanted to know up to 1 grandparent falling, which is the probability of none falling and the probability of 1 falling. In this case, like I said, it doesn't matter, but because we are looking for a discrete number, the number 0, I'm going to put false here, just so that we don't get confused. We're looking for a discrete number. We're looking for the probability of exactly 0 falling. So I'm going to put false here just so that we get used to distinguishing between those two things. But again, in this case with 0, the numbers would actually be identical. So then the answer that you have here is 0.1975. Which you could also do 0.198. The Blackboard system allowed for some decimal rounding and whatnot, and would not have marked you wrong for that. But the probability here is about 0.19, 0.20. Okay, now we want to know the probability that 1 or more grandparents will experience a fall. So we just calculated the probability that 0 grandparents out of 4 would experience a fall. Now it's asking us that 1 out of 4 grandparents will experience a fall. Now, if you think about this, it's actually asking you for the exact opposite probability. The probability that 1, 2, 3, or 4 grandparents will experience a fall out of 4, is 1 minus the probability that none will experience a fall. None is the only other option in that series of trials. So you can have 0 grandparents fall, 1, 2, 3, or 4 grandparents fall. We've already answered what the probability of none falling is. And now it's actually asking us for the opposite probability. So the probability that anywhere from 1 to 4 grandparents fall. If you recognize that from the question, then all you have to do is subtract the probability of 0 grandparents falling from 1, in which case you would get 0.802. However, if you didn't recognize that, there's another thing that you can do. However, you have to recognize that you need to do it this way. Because Excel will only give you a left-tailed probability, you either need to calculate the probability of 0 and subtract that from 1, or you need to reverse the probability. So the other option, other than calculating the probability of 0 and subtracting that from 1, is to do equals binom.dist. And now what we want is the probability of not falling. And so the question is, what is the probability that one or more grandparents will experience a fall? So the number of grandparents that we're talking about not falling is actually 0. And so here, because we need the right-tailed probability, we do 0, 4, but then we need to reverse the probability. So we're talking about the probability of not falling, which is 2 out of 3 instead of 1 out of 3. And then again, we could do true or false, but I'm going to do false. Or actually, I'm sorry, I should do true. Excuse me, sorry about that. What is the problem? Experience a fall. Oh, I'm sorry. What is so the probability of not falling is 2 out of 3, and we want to know what the probability of 0 falling is. Sorry about that. Okay, there we go. So, oops, I apologize for this. I had done this earlier, and I am forgetting something now. Oh, I apologize. So what we want here is equals. Okay, sorry. So that I don't confuse people, let me just say, calculating the probability of 0 falling and then subtracting that from 1 will give you the probability of 1 through 4 falling. Because I don't want to make this more confusing and sit here, I will just move on. But all you have to do is recognize that what you've already done is calculated the left-tailed probability. And so what you need next is the right-tailed probability. Calculating the right-tailed probability, the easiest way to do that is to calculate the left-tailed probability and subtract it from 1. Instead of confusing you by giving you a more complex way of doing it, let me just explain that a little bit more. So what you need to recognize is that when you have a distribution, Excel is only going to calculate the left-tailed probability. Unfortunately, I don't really have a little pen here that I could use. Let me see if I can draw. Sorry, I don't do this as often in a Mac, and so I am getting. Okay, never mind. So if we have a normal distribution, let me just look up an image of a normal distribution. That way it'll be easier for me. Or sorry, binomial distribution. If we have a distribution, Excel is only going to give you the left-tailed probability. So it's going to give you the probability starting at the lowest point, which is 0, and moving up. So 0 trials and moving up to the maximum, which is the total number of trials. If you want to calculate a right-tailed probability, so you want to know the probability of having 2 to 4 or 3 to 4, what you need to do is calculate the opposite of that. So you need to take the total number of probabilities minus the number that you want to calculate, and calculate that and then subtract it from 1 in order to get the left-tailed probability. I apologize that I probably just made that a little bit more confusing, but I do explain that a lot in the slides from last week. Okay, I wanted to point out that this question regarding smoking had some issues with the wording. So when it was developed, there was some accidental mistyping here. And so Professor Waldron, I believe, went ahead and gave everybody credit for this question because it was misleading. Okay, so I believe this is actually the last question that people really struggled with. And the question is, what is the z-score of a blood level of 7? So what I want to remind everybody is that a z-score is just a number of standard deviations. So anytime you're asked for a z-score, what you're really being asked is how many standard deviations away from the mean is a number. So what this question is really asking you is how many standard deviations away from the mean is 7. What we already know from the calculating from the previous questions is that the mean is 5.91 and the standard deviation is 2.6. Now, just knowing that alone, we know that 7 is going to be what? It's going to be roughly a little bit less than, or sorry, a little bit more. So 7 is going to be 1.10. So a little bit less than half of a standard deviation above the mean. In order to calculate that, we can easily put it into Excel. And all we have to do is say equals, and then we want the value that we're testing, so 7, minus the mean, 5.91. And again, remember to do these parentheses because Excel does order of operations. And if you don't do these parentheses, it is most likely going to do the division part first. So 7 minus 5.91 divided by 2 will give you, divided by the standard deviation of 2.6 will give you that z-score. So like I said, it's a little bit less than half of a standard deviation above, and that's all that a z-score is. It's just a number of standard deviations. So when you're thinking about a z-score, it can often be very confusing, but what you need to just remind yourself is a z-score is really just the number of standard deviations away from the mean a certain number is. So if I wanted to know how many standard deviations above the mean is 8.11, that is exactly 1 standard deviation above the mean, which is why I chose it. So 8.11 is just 5.91 plus 2.6. And so, 8.51, sorry about that. So 8.51 is exactly 1. The z-score for 8.51 would be 1 because 8.51 is exactly 1 standard deviation above the mean. So when you're thinking about z-scores, don't get too tripped up with the z-score table and figuring all of that stuff out. All you really are being asked is how many standard deviations away is this number from the mean, assuming that you have a normally distributed variable. Okay, so that is all I'm going to focus on. If you have individual questions, please feel free to email me either tonight or tomorrow, and I will get back to you and answer any individual questions that you have. I'm also, of course, available during my office hours on Tuesday if you want me to do a video chat with you. And then, like I said before, Professor Waldron is available on Sunday during office hours, and you can also ask during the lecture in the lab about these things. The exam in Blackboard will, again, also tell you what the correct answer was and what was really needed to get to it. Okay, thank you so much. Have a good night.